Alright, welcome back to another video from Insectech's Android Application Penetration Testing course. So in this video, we're gonna start a new module, Android Security Model. Right, so before getting the knowledge of security assessments of Android applications, it could be a Java application or it could be a native application which is developed in C++. We need to have the basic knowledge of the existing security model and what makes your apps vulnerable. That is something that you learn from this existing security model. For example, you have secure interprocess communication. If you don't use it properly, your application may become vulnerable. Right. So before getting into all of that, let's first understand the existing security model that is given by Google. So in this, we're going to see security at the operating system level through the Linux kernel, Android, application sandboxing, secure interprocess communication, application signing, application defined user granted permissions, and finally Google Bouncer. Right, we're going to discuss all of them one by one in the next couple of videos. So in this video, let's discuss security at the operating system level through the Linux kernel. So before getting into that, let's talk a bit about Google Bouncer. So Google Bouncer is basically a security check in the Android market. So if you are a developer and developing an application that's supposed to be uploaded onto the Android market, so once after completing your development process, you have to upload it onto the Android market, right? So when you are uploading your application onto the Android market, some basic checks will be performed at the Android market by Google Bouncer. So basically this Google Bouncer will act as an emulator. It simulates the environment where your application will be installed and checked for security issues like whether your application is using all the allowed APIs or if it is using anything that is not allowed by Google or something similar to that. But as far as my knowledge is considered, it doesn't really make great checks at Android market, and this is known to be bypassed. Right, so this is what is known as Google Bouncer. So let's now discuss this security at the operating system level through the Linux kernel. Right, so Linux kernel gives permission enforcement to your Android applications as UIDs and GIDs, UID and GID based permission enforcement. Every application will have its own user ID. So in general, if you're using a Linux machine, if you start a process, for example, you start Firefox, Firefox will have the process ID as well as the user ID. So process ID will be unique, but the user ID will be the user ID of the user who has logged in. But in case of Android, the user ID for every single application that is running or that is downloaded into your device will be unique. So every app that is downloaded will have a unique user ID. Right. So let's see how it is possible and how it looks like. So before doing that, we need to make sure that you have launched your lab device, which is emulator that we have created in one of our previous videos, and open up a terminal. And to check if any devices are available, you just give the command adb devices. So there may be scenarios where you are unable to get a shell on the device even if it is getting displayed in adb devices. In such cases, you type this adb kill server, because this ADB daemon is being used by different process or something similar to that. So in such cases, you may not be able to get a shell on the device. So you just type this ADB kill server. Now you should comfortably able to get a shell by typing this ADB space shell. Right. So you will get a shell on the device and it looks like this. Now to see all the processes that are running on the device, you have to type the command ps. So if you observe this output, basically this particular output which came from this ps command displays all the user IDs. Basically it is to list out all the processes that are running on the device. Now if you just scroll down and observe these processes, if you observe this, this is com.android.system.ui. Similarly, this is settings application of your device, and phone application. Similarly, music, calendar, media, MMS application, calendar again, and desk clock, and couple of other applications are running on your device. Now, if you clearly observe this email application, and if you just scroll up, if you look at the first column, this is user, right? Now, the application which is email is having u0 underscore 823 as the user ID, right? So this particular application is having its own user ID. Similarly, if you go back to the MMS application, it is having a unique ID which is A8, right? u0 underscore A8 is the user ID for MMS application. u0 underscore A23 is the user ID for this email application. So basically, all these applications are having their own user IDs. So that is how every single application that is running on your system or device will have unique ID, right? So that it will be running in its own context. So even if one application gets compromised, it won't affect the other applications that are running on the same device. Even you can see the mapping of UIDs as well as GIDs in your Android device. That's there is an XML there is a file called platform.xml file which is located in your Android device. You can go ahead and see that file, which gives the UID and GID based mapping, right? So that's all I have in my mind for this video. Thanks for watching it. Thanks a lot.